Good morning, class, and let's start today's online class. So, some concept will be revised through the PPT, and you are not able to understand, you can raise your hand, and I will clear every concept. I'm sharing the PPT. So, it is your third chapter, motion in a straight line or motion along the straight line. So, there are 14 points in this chapter. So, branches of physics, concept of point object, reference point and the frame of reference, origin of position and time, rest in motion and relative terms. Motion in a straight line, that is distance and displacement, scalar and vector physical quantity, speed, uniform, variable and average and instantaneous speed, and the velocity, uniform, variable, average and instantaneous. Difference between speed and velocity, uniform motion in a straight line, position, time graph, and the velocity time graph, non-uniform motion, acceleration, non-uniform, uniform and non-uniform, position time graph and velocity time graph of non-uniform motion, and the equations of motion. So normal equations, first, second, and third, and graphical, first, second, and third, and calculus, first, second, and third. The method of derivation, I already explained it in your class, and the relative velocity. So major portion we have already covered. So I will just try to revise it. Okay, let's start. So mechanics, what is mechanics? You can take screenshots. Na? When the page will be full up to the bottom, you can take the screenshots and note it down your physics notebook. So mechanics is the branch of physics that deals with the motion of a body due to the application of force. Whenever force is applied, the body comes into motion. When we study about these phenomena, this is called mechanics in physics. So it's a branch of physics. And the two main branches of mechanics are statics and dynamics. And statics means statics is the study of the motion of an object under the effect of force in equilibrium. So whenever the forces are balanced, then the body is in equilibrium and the body remains at rest. And when we study about that, that is called statics. That is the branch of mechanics. Next is dynamics. Dynamics is the study of the motion of the object by taking into account of its causes and their change of state or the state of rest or motion. That is called dynamic in physics. And the dynamics is classified into two categories, kinematics and kinetics. Kinematics and kinetics. Kinematics is the study of motion of the object without taking into account of its cause of their motion. It's called kinematics. So study of the motion of the object without taking into account the cause of their motion is called kinematics. That is a chapter number 3. That is a chapter number 3. And the next is kinetics. That is also the branch. Kinetics is the study of motion which relates to the action of force causing the motion and the mass that is moved. So kinematics and kinetics, both are the branches of dynamics. And dynamics is the branch of mechanics. You can take the screenshot. If you have taken the screenshot, please raise your hand so that I may move forward. Okay. The concept of point object. So let's begin with the concept of point object. So in mechanics, a particle is a geometrical mass point or a material body of negligible dimension, and it is only a mathematical idealization. So point object example, suppose that we can take ball as the point object, even a car as a point object, and the airplane and the ship traveling a long distance, and the earth. When we compare the size of the object with the distance covered by it, when the size is very, very less than with the distance covered by the object in motion, then we consider that object as the point object. So for example, if you take the example of airplane covering thousands of kilometers, if you measure the size of the plane, that will be some hundreds of meters. But the distance covered by the airplane is comparatively very, very large. So in kinematics, we consider whenever we discuss or study about the motion of such kind of objects, we take them as point. This is called point object. The concept of point object. So in practice, the nearest approach to a particle is a body whose size is much smaller than the distance or the length involved. This is the definition of a point object. Please take the screenshot. Position, path length, and the displacement. So next comes reference point. After the point object, next comes the reference point. So consider a rectangular coordinate system consisting of three mutually perpendicular axes labeled as x, y, and z axis. We know it. The point of intersection of these three axes is called origin and serves as the reference point. So we measure all things, all distances with respect to this reference point, which is called origin. The coordinate x, y, z of an object describes the position of the object with respect to this coordinate system. So whenever we describe the motion, we will use a reference point. So from where the motion begins and with respect to which point, how far is the body is. So that is called a reference point. So we have taken the example of 3D system, x, y, and z mutually orthogonal axes. So frame of reference, suppose that we have kept a clock at the origin O, the coordinate system along with a clock to measure the time constitutes a frame of reference. So a point of origin along with the measurement of time. That is called a frame of reference. Is it clear?
Yes, sir.
Okay. Take the screenshot at the end. Okay. So whenever we keep place a clock at this origin, this point, along with the origin or the beginning point, the time is included. That becomes a reference point or frame of reference. So positive direction, the positive direction of an axis is in the direction of increasing number or the coordinates. In case of left hand side with respect to the x-axis, and in above direction with respect to the y-axis, and toward this side along the z-axis. A negative direction is also taken. The negative direction of an axis is in the direction of decreasing number. When we take the direction of increasing number, that is called positive direction. And when we take the direction of negative decreasing number, that is called a negative direction. So you can take the screenshot. You can take the screenshot. Okay. So while describing motion, we use a reference point or origin with respect to which the motion of the other bodies are observed. And we can use any object as reference point. For example, car at rest or in motion can be used as a reference point. So when the reference point is at rest, that is called inertial reference frame of reference. When the reference point is accelerating, that you will study in the higher classes, that is called non-inertial frame of reference. So here we will study only the with respect to the frame of reference. So when you travel in a bus or a train, you can see the trees, building, and the poles moving back. And to a tree, you are moving forward, and to you, the tree are moving backward. It is very common, you have noticed. And both you and the trees can serve as reference points, but motion cannot be described without reference point. So we cannot describe the motion of any object without using the concept of reference point. So in the class, I have explained many questions. So we take as initial position some point and the other point as the final position. So initial position serves as the reference point. So what effect do you get when you play video games involving car racing? Take the screenshot. So origin, unit, and direction of position measurement of an object. So suppose that we are having this position, different position. At the center there is 0. When we take the increasing magnitude direction, that is called positive direction, to the right hand side, taking the direction of increasing magnitude, so it will be positive direction. Taking the direction of decreasing magnitude, that will be the negative of x-axis. So the distance measured to the right of the origin, that is positive. Distance measured to the left to the origin, that will be negative. So the origin for position can be shifted to any point on the position time graph. We can shift the origin with respect to a need. So the distance between 2 points on position axis is not affected due to the shift in the origin of position axis. So we can shift this origin to the left or right, and then there will be no effect on the object which is moving. Suppose that object covered 2 units of distance, so that will be 2 units. Origin, unit, and sense of passage of time. So we include time also. This is a position axis and it is time axis. The time measured, it is same as it was in the previous case of position. All the direction taken to the positive, that will be right, and negative to the left. So the origin of time axis can be shifted to any point, like the origin of the position axis. So you can take the screenshot. So when the same point is chosen as origin for position and time, so let's see, the origin is here. Now shift the origin, starting denoting it as O, and we have taken 3 different points A, B, and C. So at the origin, we include the time, and the position is 0, and the time is 0, means as it was in the 3D case, 3D axis, we place a clock at the origin. It is the same case. So we are including time. So O will serve as the origin or the reference point. So origin for position and time. So this is the origin for both dimensions for position and the time. And point A is position 30 kilometer on the right hand side on the positive direction, and it when the object moved to point A, it took 6 hours to cover that 30 kilometer of distance, and up to point B, it took 8 hours to cover the distance of 40 kilometer, and up to point C, with respect to the origin, I'm explaining about with respect to the origin only. So it took 11 hours by the object to cover a distance of 55 kilometers. So when the difference points are chosen as origin for position and time, so you can choose according to the question. So now we have taken this, time is negative, and the position is negative 40 kilometers. Negative 40 kilometers as the reference point. Then it will be positive 10, 0, and the 15. So instead of choosing a positive 0, we have taken the reference point on the left hand side of the 0. That is minus 40, a unit away toward the left hand side from the origin, previous origin. So origin for time is t0. Origin of time is t0. Here A is the origin for time t0, and the origin for position x0. But the motion can start from point O. So there are two different origins here. We can take at the same point both origin of time and origin for position, or at the different points. Rest and motion. So it was a very basic concept to understand these next concepts. No? So rest and motion. An object is kept over a plane surface, or we can say along a straight line. So a ball, a car, and a person. So a ball is at rest with respect to the stationary man. So this person or the man is stationary, and the ball is at rest with respect to this person. Physics is nothing without the observer. So observer is very, very important in physics. So suppose that this person is the observer. He or she is observing the motion of these objects. So car is at rest with respect to stationary man. So both the objects, this ball and the car, are at rest with respect to this observer. Now, a ball is moving with respect to this stationary observer or the stationary man. Same with the car is also moving with respect to this stationary observer or this person. So this person is declaring that the car is moving from its initial position up to a final position, and the ball also moving from its initial position to the final position. So there is a change in the state of rest and with the passing of time. So this is called motion. So rest, a body is said to be at rest if its position remains constant. So initially observer was observing that the ball and the car was at rest because there was no change in the position. So we can say a body is said to be at rest if its position remains constant or there is no change in the position with respect to its surrounding or frame of reference or the frame of reference with the passing of time. Rest is a condition. So for example, mountains, buildings, etc. There are many things are there. We can give the example of rest as a school building is at rest with respect to the surrounding. But if you see from the moon or from other planet, that will appear to move along with the rotational motion and the circular motion of the earth. So no object in the universe is at rest. We just consider the object at rest. I will explain it in the coming slide. So motion, so rest is there is no change in the position with with respect to surrounding, but when there is a change in surrounding with respect to the surrounding in the position of your object, that is called motion. So a body is said to be in motion if its position is changing. The position is not constant as it was in the previous case of rest. Here the position is changing with respect to its surrounding or the frame of reference. Frame of reference contains both the position and the time. Or we can define the change in the position with respect to time, with respect to the surrounding. Change in the time continuously change, and with respect to the surrounding. That is called motion. The moving car, buses, there are many more examples we can use to describe the moving body or the motion. So all the planets revolving around the sun are in motion. Molecules of a gas in motion above 0 Kelvin. When the gas is at a temperature that is above 0 Kelvin, all the molecules of a gas containing in the container will be at in the motion. So rest and motion are relative terms. It is very, very important with respect to the exam. Rest and motion are very relative terms. Rest and motion are relative terms. So an object which is at rest can also be in motion simultaneously. So a body can be at rest and in motion at the same time. So example, the passengers sitting in a moving train are at rest with respect to each other. The passengers sitting in a moving train are at rest with respect to each other, but with respect to the person who is observing them from outside, they are also in motion at the same time with respect to the object like trees and buildings, or a person observing them from the outside. So we are having two inertial frames. Inner inertial frame with respect to the co-passenger at rest. The bus is moving, but the person who is sitting next to you in the bus or in the car or in any vehicle which is moving, there is no gap is generating between you and the person. You are at the same point. So with respect to the interior of the vehicle, you are at rest, but the person who is observing you from outside of the vehicle or the bus, you are moving. So at the same time, an object can be at rest or in the motion. So this is called the rest and motion are relative terms. You can take the screenshot. So Abhinav, is it clear? Abhinav, am I audible? Abhinav Kumar.
Yes, sir.
Okay. Is there any doubt, students? Is it clear?
Yes, sir.
Yes, sir.
Okay. So rest and motion are relative terms. Now let's see with an example. Again, observer is here and the car is here. Car is moving with respect to the stationary person, and the car is moving with the stationary person. Now two cars are here. Both cars are at rest with respect to the stationary person. Both cars are moving with respect to the stationary person, and both cars are at rest with respect to each other because they are moving with the same velocity. Now the example of Earth. Earth is in circular motion around the sun. Earth is moving on its orbit around the sun, taking a long time of 365 days to complete one revolution around the sun or one oscillation. And Earth is also rotating about its own axis. So there are two motion in the Earth. Earth is rotating about its own axis, even it is moving around the sun. So there is circular motion, there is rotational motion. So in the example of motion of ball and car, the man is considered to be at rest, stationary, but the man is standing on Earth, and the Earth itself moving around the sun as well as rotate about its own axis. So no person on Earth can be at absolute rest. So we can say that no object is at absolute rest on the Earth. it is moving with respect to some other reference of point, frame of reference. If somebody is watching you from this space, you are moving, we are moving. I'm sitting on my couch and teaching you for the last half an hour, but there is no position change in position with respect to my surrounding. The stuff was near me, still is near me. But with respect to the person who is observing us outside the earth, so we are moving, we are having two kinds of motion, even though we are at rest on the earth. We are having rotational motion along with the earth's rotational motion, and we are having circular motion along the earth around the sun. So no object in the universe is at rest. So we only considered an object at rest. It is a consideration. Everything is universe, so continuously moving. Our galaxy is also moving. Our solar system is also moving. So our universe is also continually expanding. So no object in entire universe is at absolute rest. We only consider the object at the rest. So therefore, man is at rest with respect to the earth, but is rotating and revolving around the sun. So it is a very important concept of kinematics, initial important concept. So take the screenshot. Okay. So we can say rest and motion are relative terms. They are related to each other. Rest and motion are related to each other. So these are the examples of motion. Our galaxy is continuously moving. A ship is sailing in the ocean. A man in the ship is running on the board. So these are many cases. No? You can write any one. You can take the screenshot. We can imagine many more things to describe the motion and the relation between rest and motion. There are 12 examples I have displayed here on my PPT. You can write many more examples. Now, motion in 1, 2, and 3 dimensions. One-dimensional motion, the motion of an object is said to be one-dimensional if only one of the coordinate is changing. One of the coordinate is changing. One of the 3 coordinates is required to be specified with respect to time, and it is also known as rectilinear motion. But when the object move along a straight line, then the motion is called a rectilinear motion. Suppose that only one coordinate is changing out of 3, x, y, and 3, z. If you take the object into the space, there will be 3D system and x, y, z axis, and the object is moving only along a particular axis, x, y, or z. Only one coordinate will change, the other will remain the constant. In that case, the motion is called rectilinear motion. For example, if you have dropped some article near the surface of Earth from your hand, if you drop something from your hand near the surface of Earth, the body will be in free fall, but it will describe rectilinear motion. It will follow a straight line coming to the surface of Earth. So in such a motion, the object moves in a straight line. The motion along the straight line. This is the name of the chapter. So example, a train moving in a straight track, a man walking in a narrow leveled road. Two-dimensional motion, when 2 coordinate out of 3 changes. For you are suppose that there is a 15th of August, many people flying the kites. You enjoy kiting during this season. If you do kiting, if you play kiting, it will have 2 dimensions: height from the surface of the earth and the distance from you. So there will be 2 axes, x and y. So this type of motion is called 2-dimensional motion, that we will study in the coming chapter. So ant moving on a floor, a billiard ball moving on a billiard table. So zigzag motion, we can say zigzag motion. And the three-dimensional motion of an object said to be three-dimensional if all the three coordinates are required to be specified with respect to the time. When we launch the rocket, we use the rocket should be in three-dimensional motion. We measure all the direction with respect to three axes, and we describe the motion of the objects in the space. So such motion takes place in space, 3D motion. A flying airplane, bird, kite. Kite sometimes consider very near the surface of Earth in 2D motion with respect to height and distance. So sometimes we take it as a 3D motion. You can take the screenshot. Okay. So path, a line joining the successive position of a moving body is called its path. So the length of actual path between the initial and the final position gives the distance so traveled by the body. So distance is a scalar quantity. Scalar quantity means the body have magnitude only. The physical quantity have magnitude only, and there is no importance of direction in that case. So displacement or distance is a scalar quantity. And what is distance? It is actual length of path, or we can say the length of the actual path between initial and the final position. But when we take the actual length of path, it means the distance covered by the object during its motion with the passing of time. It may be curve, it may be a straight line. So it's a scalar quantity. Example. So this is the direction north, south, east, and west. Suppose that this person is moving along the straight line. So one of you boys, you are moving along these lines. So 5 kilometers and 2 kilometers. So distance traveled is 7 kilometers. So there is no importance of direction. So up to the end of 5 kilometers, this person was in the straight line. Then he changed his direction and covered 2 more kilometers. So there is no importance of direction in this case. So the total path length is 5 plus 2, 7 kilometers. So this is called distance. So distance is a scalar quantity. It has the importance of magnitude only and not of direction. So now consider one more person, the same person moving again. Now he comes back to its initial position. After covering 5 kilometers, he goes up to 5 kilometers and returns to its initial position. In this case, who will give me the answer? Answer is already. Who will give me the answer?
Sir, distance
Total
traveled is
distance
10 kilometers.
Sorry? Hello?
Sir, distance traveled is 10 kilometers.
Yes, 10 kilometers. There is no importance of direction. 5 to the right side and 5 to the left side. And he comes back to its initial position. The total distance covered is 10 kilometers. Now the displacement. Displacement is a directed line segment joining the initial and the final position. Less than 1 minute is remaining, students. The class will be off. So I'll covering it. If you want, I can take class 1 hour more, 40 minutes more. Will you come back? Okay, let me explain it. No answer means not interested. So displacement is a directed line segment joining the initial and the